Hello, and welcome back to the sim. In this one, we're jumping back in with SPAD.neXt and version 0.9.15 to look at how are we doing LEDs now. This is also kind of a new user video since we never really covered just specifically controlling and programming LEDs. And with the new implementation, this is the perfect time. So most devices with LEDs are going to show up under either the panels page or, for example, the FIPS, where we may have FIPS and they have LEDs on them. And all these devices now use the new LED system. So things have changed, and specifically with the multi-panel, that also means things like short mode and long mode, but we will cover that in an update video. What we're talking about right now is how we make these LEDs turn on and off. The way it used to be done, you had to have, say, two conditions. We had to have two entries for turning the LED both on and off, even when it was something as simple as tracking the heading lock. Now, that made it way more powerful. We could have multiple conditions. We have on, we have off, we have flashing, we have 2-second flashing. We have all these different things that can determine what turns the LED on and off. There needs to be an easier way for things that are simple. And this is a great example for that. Heading mode has an on or an off. There are no alternate modes usually that we need to assign. Now, sure, I could do something with flashing because I want to repurpose the LED, but let's use the basic example of heading mode. Well, we no longer need this off event, so we're going to delete it. But wait, Les, it's not going to turn off now, right? Well, correct. As you can see, we're toggling that a whole bunch of times, and the count does go up for this condition being met, so turn the light on. But the light never goes off. When we edit the event, so double clicking on it or hitting the edit button, we have our condition, and of course currently the condition is met because the value is 1. If we toggle it again, I know that the heading mode is off. You'll see that the condition is not met. So the X just means currently heading lock does not equal 1. So it would not turn the LED on. So normally when editing this LED, you have the device, you have the target, because yes, you could put the condition on one device or a random button, but control another device's LED. Usually not the best thing to do. You want to keep them together, but you could do it. So here we want the light to be on, so static value is on or off. Then you have the mode, and that's where we have it for permanent, meaning solid lit, or you could have a slow flash where it toggles 2 seconds on and off. You could have a fast flash at 1 second, a faster flash, or a flash once and then goes out, or flashes once and stays on. Can't remember. Does one of those two things. Try it out. Let me know. You can also now invert the data value. So this got added because there was a backwards data var. I don't know exactly which plane or which sim it's in. Might be an X plane. But there is a reason for having this where the var is backwards. A Boolean of 0, so you want it to be off, is actually the on, and the 1, which should be the on, is actually the off. So you could invert the data value. So now we've got this cool new checkbox for auto off. So this is going to turn the LED off automatically if the condition fails. And so now we know that it turns it on, but we have auto off enabled. When we click OK, you'll see the light goes out because the condition failed, so it automatically triggered the auto off. So for the count, the number of times it's fired, we can see, because this has been reset, that we've now edited this event. The only thing that was valid was to automatically turn it off. So if we trigger the mode again, now we've set the value to 1 because we've turned on the autopilot heading hold mode using the toggle event of the button. You see that the count for turning the LED has gone on and the LED has turned on. Press it again and the toggle is sent. The sim processes that toggle, which is to turn off the autopilot mode, and now we can see that auto off is triggered. That's so cool! We've now got the ability for a lot of LEDs where we have an on and an off state to no longer have to program 2 events. We only need the one event with auto off. But wait, there's more. Benefit of this and why there's auto off to begin with is, yes, we could have slightly more complex conditions where we have an additional variable or two set with an and or an or. What kind of example? Well, let's say you had on the Bravo the engine fire. Maybe I need it that it's engine 1 equals 1 or engine 2 equals 1 because it was a multi-engine. If it was, for example, the Boeing 747 with 4 engines, I'd have an or condition and I'd have it for all 4 engines. And so the beauty here is, again, I don't need to create another one that checks all of those and validates that they're all 0. So using an and condition for all 4. The fact that none of those variables would be true would mean that it would use the auto off. So again, makes life a lot simpler when we have a bunch of conditions that we need to check. But in this case, we can make it even more efficient. Now you say, how much more efficient do I need? I got multiple cores. Again, we're talking minuscule amounts, but hey, maybe you have a lower end system, fewer number of CPU cores, and you have a lot of things processing, and SPAD CPU usage is a concern for you. How do you reduce the amount it has to process checking this? So instead, what you can do is remove the conditions altogether. Now, normally, this would trigger this and say, hey, you can't actually turn something on or off without a condition. That is until you change how it's being referenced. So now we don't need this, which the auto off, so it has to validate constantly the condition. And instead, we're now going to directly tie this to that heading lock variable. So heading lock, so we know what it is, autopilot heading lock, Boolean. So now that we've tied it directly to this, we no longer even need a condition for it. So now that we've done that, now that LED, a 0 will set it off, a 1 will set it on. And if you wanted to, sure, you could still have it that it's, instead of a permanent mode, it was going to say go flash mode. And so now it's flashing based on that variable. Click it, it goes off. Click it, it goes on, and that value of 1. So this holds true for these Booleans and setting 0s and 1. Now you could take this one step further. Maybe you do have some conditions and you need a combination of ands and ors. Remember, there is no way to set one condition with an and another condition with an or. Instead, that's where you would have had to build an expression. Well, you can now tie that directly in using the expression. So here I could add data and add multiple data variables, and then I could write that if statement, that or, that and, so you can create the logic directly inside of here to drive the Boolean to 0 or 1. This is now the standard way. So if we come over here and we come to our heading dot, we would have been able to paste this, and now it automatically linked it to the serial device, in this case our FCU, and to the heading dot, all tied to that same exact variable. Looking over here, you'll see that we've already gone and attached it here as well. So yes, all of these devices with LEDs and lights are now utilizing this same interface, and we can easily copy, paste, and move these between one another. So this is the new way of doing LEDs. I think it's super cool how this is now tied in. It's gonna make life for mapping this stuff a lot faster, a lot easier, and a lot more consistent from device to device. With that, we're gonna go ahead and get out of here. I wanna fly the H-Jet, it's been a while. So guys, if you made it this far, please hit that like button. Subscribe if you haven't. Come along to the next one. As always, thanks for watching. Have a great day.